All right, so in this slide, we are going to be introduced to the idea of trying to expand, or in this case, multiply out binomials given some power. And so if we look at this bottom row here, and we talked about this last week, the idea that we can use Pascal's triangle to help us make these problems easier moving forward. So in this case, we have generic binomials of a plus b to the n power, where n is that exponent value. And what that n is going to tell us or help us do is it's going to help us understand what row of Pascal's triangle we need to be accountable for. So as we look here, we can kind of notice that we're seeing in this coefficients only column, this is Pascal's triangle to some degree here. And what they're doing is they're showing you how they would expand, or what it would turn out to be if you expanded these various binomials of different values. One of the other things I want you to pay close attention to in this slide is what's happening with your exponents. Notice in each row, well, in this case, there is no 0 because anything to the 0 power is 1. But in this case, you've got an exponent of 1. Notice how each of the items has that exponent. And at any given time, each term has a maximum exponent count of whatever that is. So down here, we've got 2. So we've got a to the second. And then the next one over, a loses 1, and then b gains 1. And at the end, a disappears and b has all of the exponent values. The same pattern applies here for the third. We've got a to the third. The first term gets it. It loses 1. The b gets 1. It loses another one, then b gets it, and then b has all 3 of the exponent values. But all of these terms have at most 3 as their exponent value because that's what it was originally. And so this pattern continues as you move down. So just keep that in mind moving forward. All right, and so here we talk about this coefficients only column matches the numbers in Pascal's triangle. And so in this case, it's introducing us to who Pascal was, a French mathematician from 1623 to 662. And this triangular array of numbers in which the first and last number of each row is 1, and each of the corresponding numbers in between is the sum of the 2 numbers above it. Using Pascal's triangle, we are able to figure out the coefficients of our terms in our binomial expansion. So we'll know that what the coefficients of our polynomial should be or could be affected by. So in this case, these are the values that will affect the coefficients of our terms of our polynomial. And so we're going to use Pascal's triangle, in addition to that little information I just talked about with the exponents, to help us put together binomial expansion without having to use FOIL or the distributive property. But like I said on Friday, if you're more comfortable with the distributive property, or foiling, you can use that as opposed to this method. This method is just a little bit quicker than using FOIL as we reach larger exponented binomials. So in this problem, it's asking us, what is the expansion of a plus b to the 6th power? Use Pascal's triangle. And so what we're going to do is we're going to use Pascal's triangle to expand this binomial. So we're going to list out Pascal's triangle through row 6 and then go from there. So I'll go ahead and write it 1, 1, 2. And so in this case, I see that we've got row 0, 1, 2, 3, 4, 5, 6. So this is the row we're going to use. These values represent the coefficients of our binomial expansion here. And so what we have to recognize is that each of these items here is a different quantity. We've got A, we've got B. And so we're going to use these to attach the coefficients and the variables where they need to go. But what we have to understand is that we're looking at, in this case, this exponent of 6 is going to get applied to both of these items in different ways. So let's just start with the first term. We know the coefficient is going to be 1. In this case, if you think about if you were doing FOIL, it's that first item times itself in the next part. And so in this case, we'd actually end up with whatever this first value is to the 6th power. So that'd be a to the 6th power. The most exponent value we can have in any term of this polynomial is 6. So if a has all 6 of the exponent, b would have none. So we could write b to the 0 here or just leave it off. Then we'll move to the next term. We've got 6a, and this time a is going to lose one of its exponents, a to the 5th, but then the b is going to gain the next one. Then we'll go to the next part. We'll go 15, a to the fourth, b squared. Notice how they're trading off exponents as they go. 20, a to the third, b to the third. Then we got 15, a to the second, b to the fourth. I'm going to have to remove part of my Pascal's triangle here. I'm going to run out of space. All right, so I'll move that. And then I've got 6, a to the first, b to the fifth. And then last but not least, a would get none of the exponent, but the b would get all of it, so b to the sixth. And so we have 1b to the sixth power. And so this would be our expanded binomial. So if we FOILed this out, so a plus b times 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 a plus b 6 times, this is what we would end up with for our polynomial. And keep in mind, the ones we don't necessarily need here, but I'm going to leave them for the time being. And we did this, or we found the coefficients using Pascal's triangle. The only thing we had to worry about from there on out is how the exponents change from one end to the other. So let's look at another example. All right, so here we've got 2 examples. Ideally, we have to be able to go from the third power to the fifth power, so we need Pascal's triangle through at least the fifth row. So 1, 1, and we've got 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, and 1, and then 1, 5, 10, 10, 5, and 1. So the bottom here, we've got row 5, and then right here, we've got row 3. So we'll use this one for 1, and then we'll use this one for 2. So let's see if we can expand these. So in 1, we've got our 2 quantities. We've got x and a. So we'll start with 1 x to the third, a to the 0, so we don't need to write it, plus 3 x squared, a to the first, plus 3 x to the first, a squared, plus 1 a to the third. So if we wanted to, we can simplify this a little bit, make it look a little bit nicer. We don't need all the extra ones on the exponents and such, but... And so this would be our answer. Question 2 is very similar, but it is slightly different. Notice here, instead of dealing with just variables, we now have one quantity is x, the other quantity is a -2. So we're going to have to simplify towards the end of this problem. So let's take a look at how this works using our fifth row of Pascal's triangle. So 1x to the fifth, -2 to the 0, so we don't write it. So we say plus 5, x to the fourth, and then -2. I'm going to put that in parentheses. Then we move to the next one, 10, x to the third, -2 to the second. So this had a first, this is the second. Notice that the x and the -2 are still trading off values as if the -2 were a variable. And we'll actually have to simplify at the end, but for right now, let's just keep writing this out. And then 5, x to the first, -2 to the fourth, plus 1, -2 to the fifth. So now we just need to simplify this. And so what I mean is here, 1x to the fifth, we can just write as x to the fifth. Here we've got 5 is a value. -2 is also a numerical value. So we can multiply these two together. So this becomes -10 x to the fourth. You're going to multiply numbers together as they are. Here we've got -2 squared, so this is a +4. So we're going to take the 10 times the 4, and you're going to get 40 x to the third. -2 to the third power is -8. We're going to multiply these two together. We get -80 x squared. -2 to the fourth power is 16. Multiply these two together. You're going to get 80x. And then -2 to the fifth power is going to be a -32. So So we're going to bring negative 32 down here. So this is our simplified form. So the change, in this case, the sign in between, as well as adding in a value as opposed to a variable, changes the process slightly. But once you get in the habit of putting the items where they belong, the simplification process shouldn't be too bad. All right, so let's look at another example of this. And then we'll look at one more challenging problem towards the end. So here it says, what is the expansion of x minus y to the fourth? Use Pascal's triangle. So in this case, we've got two values. We've got x and we've got negative y. So understand that negative y is just negative 1y, like this. Same idea. If it helps you to write it that way, go for it. But we need to keep account of that we're going to the fourth power. So we need to create Pascal's triangle through row 4. And so we've got row 0, 1, 2, 3, and 4. And so row 4 here. So with this, we're then going to go ahead and expand this. So we'll start with 1, x to the fourth, y, negative y to the 0 is going to be 1, so we don't worry about writing it, plus 4, x to the third, negative y to the first power, plus 6, x squared, negative y to the second power, plus 4, x, negative y to the third, plus 1, negative y to the fourth. So now we just need to simplify what we have. And so x to the fourth stays. This negative y to the first power means this negative 1 stays negative. So we're going to take 4 times negative 1. So this is negative 4, x cubed y. Here we've got negative y squared, so that's going to be a positive y squared. So we're going to leave the 6 positive, so x squared, y squared. The negative y to the third, that's going to be negative y cubed. So we'll take the 4 times the negative 1, that's negative 4, x, y to the third. And then at the end, negative y to the fourth is going to give us a positive y to the fourth. So this is plus y to the fourth. All right, so we want to take a look at one more problem. But ideally, what we've been doing here is we've been using Pascal's triangle to get our leading coefficients for our binomial expansion. In addition to that, I want to introduce real quick just this idea of something called the binomial theorem. And that's what we've been doing in terms of how we've been using our exponents and Pascal's triangle to create the polynomial that is represented by that binomial multiplication. You're not going to be expected to memorize this, so you don't necessarily need to write it down. But that's what we're using. We're conducting this expansion through the binomial theorem and Pascal's triangle. So in this problem, it says, what is the expansion of 2x minus 3 to the fourth power? So once again, we'll just go ahead and write down Pascal's triangle. And so we only need through the fourth row because we are doing a fourth power. So we'll use row 4. Remember, this first row is row 0. All right, and so we're going to go ahead and expand this, but understand we've got values of 2x and negative 3 here. These are two separate quantities. So we'll start right off the bat. We'll go 1 times, in this case, 2x, and it's going to get all of the exponent to the fourth. The negative 3 doesn't get any exponent, so we skip it. And then we go 4 times 2x to the third times negative 3. Then next we've got plus 6 times 2x squared times negative 3 squared plus 4 times 2x to the first times negative 3 to the third plus, in this case, 1 times negative 3 to the fourth, and the 2x doesn't get any of the exponent. So at this point, we need to simplify this. And in this case, we want to make sure we're paying close attention to how we're simplifying it. It's going to be a little different than what we saw before. So in this case, This 4 exponent is going to get applied to the x and the 2. So we're thinking in this case, 2 to the 4th power in this case is going to be 16. So 1 times 16 makes this 16 x to the 4th. Then we do the same thing here. 2 to the 3rd power is 8. 4 times 8 is 32. 32 times negative 3, because we're going to multiply all the numbers together, is negative 96. And then we have x to the 3rd, because this also gets applied here. And then we've got 2 squared is 4, so 6 times 4 times negative 3 squared, which would be 9. 6 times 4 times 9 is going to be 216. And we've got our x squared. We've got 4 times 2 times negative 3 to the 3rd is negative 27. So 4 times 2 times negative 27 is negative 216x in this case. And then last but not least, negative 3 to the 4th power is 81. So we then tack on the 81 here. And so this is our answer. Can't remember this method? You can use FOIL or crab claw to do this multiplication. It will take a lot more work, but if you're more comfortable with that method, go ahead and use that method for solving. So you can always go back to using FOIL or the distributive property to multiply this out the long way, or you can use Pascal's triangle and the binomial theorem to make this a little bit quicker, as long as you can remember the rules.